Hello everyone, in our last videos we have seen our first two modules of mathematics 1, engineering mathematics 1. The first one was matrix. We have seen how we can solve matrix, how we can find consistency of a system, how we are dealing with Cayley-Milton theorem and various other topics. In our second module we have seen calculus of functions of several variables. We have learned a new concept of partial derivatives. We have seen Euler's theorem, Jacobians, maxima and minima of when we have more than one independent variable. Today we will begin with our third module, that is infinite series. Before beginning this module, let me have a detailed brief idea about the module. This infinite series, to have the knowledge of infinite series, first we need to understand what is a sequence. We must be knowing what is a sequence. Then that sequence can be finite, that can be infinite, and then when we can proceed to a series. Then series again can be finite, it can be infinite, and then we can see what are the various things that we can learn or that we can infer in this infinite series. The topics which I will be dealing in this module will be first sequence, then we will see what is monotonic sequence, what is bounded sequence, then we will see what is limit of a series, limit of a sequence, then convergence, divergence, whether the sequence converges or not, then what is oscillatory sequence, then infinite series, then convergence and divergence of infinite series. In the first few videos we will see only the convergence of positive series, positive infinite series. Later on we will switch to negative terms or alternating series. Then we have one theorem here, very important theorem, that is Leibniz theorem. With the help of Leibniz theorem we can conclude whether, we can check whether a series is, whether an infinite series is convergent or absolutely convergent. So we will go brief one by one all the topics. Let's begin with the very basic topics. The first one is sequence. So we must be knowing what is sequence first. Let's begin with the example only. Let's say we have 2, 4, 6, 8 or 10, 12 and 14. So this is an example of a sequence. A sequence is a set of real numbers which follow a certain pattern. This is a sequence. It is following a certain pattern where we can see the common differences here is 2. That pattern can be anything. Sequence can be finite and it can be infinite. This is an example of finite sequence, and if I proceed it can be example of infinite sequence. Then we have to check what is, we must be knowing what is monotone sequence. But before learning what is a monotone sequence, we have to learn what is monotonic increasing and monotonic decreasing. Monotonic increasing means ai will be less than ai plus 1, and monotonic decreasing means ai will be greater than ai plus 1. It is simply whether the sequence is in an increasing order or whether the sequence is in a decreasing order. For example, the first example as I have written over there, this is a monotonic increasing because our this ai is less than the next number. So it is monotonic increasing. Or if I say, let's say 10, 8, 6, 4, this is a monotonic decreasing because first number is less than the other number, or first number is greater than the next upcoming number. So this is monotonic decreasing and this is monotonic increasing. We say a sequence is monotone sequence if it is either monotonic increasing or monotonic decreasing. It's very important to notice here, or a sequence is known as monotone sequence if it is either monotonic increasing or monotonic decreasing. It has to be any one of it. then it is known as monotone sequence. After this monotone sequence, we are having one bounded sequence also. Let's see what is this bounded sequence. Again, for learning bounded sequence, we have its two types. One is it is bounded above, and one is it is bounded below. For bounded above, we will have one real number capital M such that AN is less than, it is not greater than, is less than. It is less than equals to that capital M. And for bounded below, this AN has to be greater than equals to capital small m. Let us take an example for that. We say a sequence is bounded above if our sequence is less than or greater than a real number, say capital M, and we say it is bounded below if our sequence is greater than equal to a small say real number, which is I am denoting with small m. And we say sequence is bounded sequence if it is both bounded above and bounded below. So here we will use the word and. A sequence is bounded sequence if it is both bounded above and bounded below. Bounded above, our sequence will be less than one real number capital M, and in bounded below our sequence will be greater than or equal to a small number, which is let us say small m. And bounded sequence will be a sequence which is both bounded above and bounded below. Let us take for one example for bounded sequence. If I say 1 upon 2 square, 1 upon 2 or 1, 2 cube, 1 upon 2 4 and so on. This is an infinite sequence. See, our sequence here will lie between, or let us say here 0, we are having 0 here, 0 and 1. That means our sequence will be greater than a small m, that is here 0, and it will be less than capital M, which is 1. So it is both bounded above and bounded below. All the values of the sequence will lie between this certain age 0 and 1. That we can see. No values can be less than 0 and no values can be greater than 1. So this is an example for a bounded sequence because it is both bounded above and bounded below. We always represent bounded sequence with such format. Let it be minus k a1 and this is plus k. So this is the example for a bounded sequence. Let us take one more example which is not bounded. Say, let us say 2 की power n. This is the general formula. So the sequence generated will be 2 raised to power 0, it will be 1, then 2, then 2 square, then 2 cube, 2 4 and so on. So we can see the sequence is not a bounded sequence because we are having a lower limit 1. All the values of the sequence will be greater than this 1, but we are not having a upper limit there. So we can say this is not a bounded sequence. It is bounded below but not bounded above. Therefore it is not a bounded sequence. Because for a bounded sequence, the sequence has to be both bounded above as well as bounded below. So this is not a bounded sequence since we are not having any upper limit there. So this is bounded sequence. After that, let us see what is limit. Limit of a sequence. Generally, we are done with bounded. Limit of a sequence, we define limit with an minus L is less than equals to a small number, say epsilon, or it can be written as limit n tends to infinity an is equals to L. That means when n is tending towards infinity, then an will be tends to a number L, and this L is what we call as limit. And if we are for any sequence, if we are getting the limit, we say that the sequence is converging. If we are not getting this L, then we say it may not be converging. This limit is very important. If the limit turns out to be a finite number, we say our sequence is convergent, and if the limit does not come out to be a finite number, let us say it is minus infinity or plus infinity, then we say it is not convergent. So, we can conclude that a sequence can be convergent if limit is finite and a sequence is divergence if limit is not finite, maybe minus infinity or plus infinity. Let us take example for that. Let us explain with the help of example. If I take any example, let us say 1 upon 2 की power n. This is a general formula. So, it is let us see, this is our general price formula, this is our sequence an. Let us check whether it is convergent or not. So, using the definition of limit as I have discussed earlier, an is 1 upon 2 raised to power n. Now, n is tending towards infinity, so the denominator will be infinite, and 1 upon infinity is 0. So, the limit is 0, which is a finite number. This is a finite number. So, we say 1 upon 2n is convergent. This is how we are checking for convergence of a sequence. If we are finding the limit, if the limit is a finite number, then we say it is convergent. If the limit is not a finite number, we say we call it is a divergent. I can take the example for divergence as well. Let us take some other n. Let us say n square. So, it will be limit n tends to infinity n square. N is tending towards infinity, so the result will be infinite. So, we can say it is divergent. Divergent means the limit is infinity, the limit is not finite. So, it is divergent. This is how we are checking whether a sequence is convergent or divergent. Also, we are having some of sequences which are neither convergent and nor divergent. Such sequence we call them as oscillatory sequence. These are the sequences which neither converges nor diverges. These are oscillatory sequence. For example, 1 minus 1 1 minus 1 1 minus 1. This is the example for oscillatory sequence. We can see it will neither converge nor diverge. So, such sequences are known as oscillatory sequences. So, we are generally limit, convergence, divergence, oscillatory. Now, coming to the main module, our main chapter, that is infinite series. What is infinite series? So, we have studied sequence. Sequence is a set of set of real numbers followed with a certain pattern. Now, sequences or series. We write series like U1 plus U2 plus U3 plus U4 plus U5 up to UN. This is a series. Now, series may be finite or series can be infinite. Series can be finite, series can be infinite. The one I have written above is a example for finite series, since we are having n number of terms there. For infinite series, we write it down like U1 plus U2 plus U3 UN and so on. This is example for infinite series. This is a finite series, this is a infinite series. In this our entire module we will be dealing with this infinite series. How we are checking this in, how we are solving this infinite series is, what we need to do is, we need to check whether our infinite series converges or not converges. See, we cannot solve infinite number of sums, infinite number of terms. For infinite series, we cannot calculate infinite number of sums. So, what we are doing is, we are taking a part of this, we are taking n part of this, that is Sn. We are taking Sn, where Sn is U1 plus U2 plus Un, and we are checking whether this Sn is convergent or not. If this Sn is convergent, we say infinite series is convergent. If this Sn is not convergent, we are saying infinite series is not convergent. So, since we are having infinite number of terms, what we are doing, we are just taking n number of terms here, and we are denoting that n number of terms to be Sn. If this sum of n terms, sum of n terms is convergent, then the series is convergent. If it is not convergent, then the series is not convergent. And again, how we are checking for convergence and divergence? We are checking convergence and divergence with the help of the limit. If the limit is finite, we say it is convergent. If the limit is not finite, we say it is not convergent. For example, I will take one very good example. Say first n natural numbers, square of first n natural numbers. So, it is 1, then it is 2 square, 3 square, 4 square and n square. If I calculate this Sn, then we know sum of n natural numbers is, square of n natural numbers is n into n plus 1, 2n plus 1 upon 6. If I find the limit of this Sn, limit of Sn where n tends to infinity, then we will see its limit will be infinite. So, we can say it is divergent or it is not convergent. So, what we have done is, we have to find, or let us say see, we have to find whether this infinite series converges or not. So, what we have done is, we have taken n numbers from the series, from our series, and what we have done is, we have just find Sn, that is sum of n, square of sum of n square of n natural numbers, that we already know, it is n into n plus 1 to n plus 1 upon 6. Now, we are putting limit on this. If the limit turns out to be a finite number, we call it convergent. Since here the limit is infinite, so we call it is not convergent. So, this is one way to check whether the infinite series is finite or infinite. It is one way of checking whether the series is convergent or not. But we have certain very good test from which we can directly check whether our infinite series is convergent or not convergent. But before going to the test, we have one or two important infinite series which we will be seeing in our next video. Till then, thank you.